Students will be able to find the average value of the function using an antiderivative. Now my claim on this first slide is that if you take the integral from 2 to 5 of 2x dx, that is the same as finding area under the curve. In this case, we have a straight curve. We have a line. So we finally get to a section where we're actually doing the antiderivative, where we're going backwards with this. So we assume this is the derivative, and we're going to back up to the function. So the antiderivative of this is x squared. The derivative of x squared is 2x. And then we're going to evaluate this from 2 to 5. Now I should really write from x equals 2 to x equals 5, but we tend not to write those. We kind of shortcut it. So that's equal to 25. And you always subtract. So you plug in the top value, always subtract, plug in the bottom value, and you get 21. So my claim is the area under the curve 2x from 2 to 5, this area right here, I claim that's 21. So the area of a trapezoid is 1/2 times the height. The height here is actually 3. Base 1 is the y value for 2, which is 4. And then base 2, and you can interchange those, is the y value at 5, which is 10. So 3/2 times 14. 14 divided by 2 is 7, times 3 is 21. So doing this integration stuff is the same as finding the area under that curve. It's the same thing. So hopefully this fairly straightforward example shows you or convinces you that that's what we're trying to accomplish. Any questions? Interpret the integrand as the rate of change of a quantity. In other words, interpret the integrand as a rate of change. In other words, as velocity. And evaluate the integral using the antiderivative of the quantity. So in other words, we're just finding the integral. But that's what they mean by rate of change. It's the derivative. So let's do this one by hand, and then I'll show you a bunch of stuff on the calculator. What do you take the derivative of to get this? What is it? Inverse sine, right? So the antiderivative is inverse sine of x, and we're evaluating from 0 to 1/2. So we want the inverse of 1/2 minus the inverse of 0. So where is sine 1/2? Pi over 6. And sine is 0 at 0. So the answer is pi over 6. So let me show you a couple ways to get this value on the calculator. If you want to play along, grab your calculator. If you go to math, we learned, and we don't do this much because we like to do stuff in here more by hand than actually using the calculator. But for calculator parts of the test, we certainly want to know what are our options. For derivative, we had n derivative, and you can find the derivative of a function at an x value. Well, here you can find the integral of a function between two values. So there's fn int, or math number 9. We're integrating from 0 to 1/2. And we're integrating 1 divided by square root of 1 minus x squared. And we're integrating with respect to x. To compare, we'll have to do pi divided by 6 to see if it's the same. So press enter. And if we do pi divided by 6, it's exactly the same. We got it. Math number 9. Let's try other ways to do this. I'll pretend I haven't done this yet. In y1, we could put 1 divided by. I don't need parentheses because square root kind of serves as the parentheses. 1 minus x squared. If we go the standard zoom, zoom 6, we find out that this is a very small graph. So we'll zoom in. I like the zoom box. So you get the corners. You can just do the zoom in if you want. And we see the graph a little better. And we're integrating from 0 to 1/2. So if you go to calculate, just like you can calculate values and zeros and mins and maxes and intersections, you can calculate values of derivative and values of integral. So if I go down to number 7, or just hit 7, I'm integrating from 0, left limit, to 1/2, or I'll just put 0.5. It actually shows the area under the curve and then tells you what the value is, what the area is. So it even shows you area under the curve for that. Now the last thing I want to show you, any questions on this? Now that we have the equation in y1, let's say that we had a free response question where we had to graph it, we had to find derivatives, we had to find zeros, we had to use the graph. And then part D, we have to use the integral of this. Well, you don't have to type the whole equation in again. You could go math, number 9, from 0 to 1/2, or 0.5, I guess. You don't have to type it all in now. You can use what is in y1. And you hit variables. Arrow over to y variables. This sounds like a lot, but it's less than entering the whole equation in again. Variables, y variables, and our equation is in y1. We're still integrating with respect to x, though, not y, with x. Press enter, we get the same answer. That's nice later on when we work with two functions and we have to subtract them. We have to graph them and then do the integral of the subtraction. Rather than re-entering the functions in, it is much easier to go to those y variables, especially when you get used to it. Y variables, arrow over, enter, enter, and you got it. All right, anyway, let's do this one by hand. Because of the one that I want you to try at the very end of the notes, this is the same as the integral from 1 to 4 of negative 1 over x squared. This is the one that I actually don't want when I do antiderivative. So if you get this right here, if you had, oh, hello. So it requires computers, if you choose not to restart, remind me later. Okay, cool. If you were to get the integral of 1 over x to the third dx, you would want to change this to x to the negative 3, because then you can just do the reverse of the power rule. So I actually want this form of it right here. I want what 30 says. Now, to take the derivative, we subtract 1 from the power. So antiderivative, we add 1 to the power. So x to the negative 1. But now if I took the derivative of this to get back to the original, wouldn't I multiply by negative 1? And I would get that negative. So do I want an extra negative here, or do I not want it here? You do not want it here. No. So this is x to the negative 1 from 1 to 4. In other words, 1/4. 1/4. I was thinking 4. 1 over x from 1 to 4. So we plug in 4, plug in 1, and it's always subtraction. 1/4 minus 4/4 is negative 3/4. Math. You don't have to do this unless it says it somehow in the instructions. 1 to 4 of negative x to the negative 1. Oh no, is it 2 to the negative 2? dx should be negative 0.75. There it is. Got it. Here's the thoughts I had this morning. Hopefully, it doesn't change how you do the math. It might change how you understand the math. So let's say I had some test scores, And the test scores were 90, 85, 84, 78, and 73. Without adding them up and dividing by how many there are, do you think you could fairly accurately predict what the average of those numbers are? What would you guess? Would anyone in here guess 89? Would anyone here guess 72? How about 80, 84-ish, 83-ish? That seem more reasonable? Yeah? That seem like a reasonable answer? Okay. Because I need to find a number where if I added the numbers above that number, it should be about the same as adding the numbers below that value. Would you agree that's kind of in general what average is? Seem reasonable thought? Average value is central tendency. What point on the line would you find about the same amount of values above as below? So if I go from 2 to 6 on a line, where would about the same amount of y's be as below? The thought I had this morning is it has to be the midpoint. It has to be. There's no other value it could possibly be. So let's find the midpoint on the line y equals 2x plus 1 from 2 to 6. So we have the point 2, see 4 plus 1 is 5, and the point 6, 13. The average value on a line has to be the y value of the midpoint. Because that's where, if I added up all the y's, which you can't do that, you can't add up all the y's. There's an infinite amount of y's between any 2 points. But if we could add up all the y's and divide by infinity on the top, add up all the y's and divide by infinity on below, it has to be the midpoint. The y value of the midpoint. And you find the y value of the midpoint, well, let's get the whole thing. It would be 2 plus 6 divided by 2, comma 5 plus 13 divided by 2. So the midpoint is 8 divided by 2 is 4. 5 plus 13 is 18 over 2 is 9. The midpoint has to be 4, 9. 4, 9 right there. My thought this morning, I did not know if I was correct, the average value of the y's on that function has to be 9. It's got to be. There's no other way it could not. I thought this morning it's got to be. There's no other number it could be. So then I tested it. To find average value of a function, you take 1 over b minus a, 6 minus 2, times the integral from a to b, 2 to 6 of the function, which is 2x plus 1. Stop doing 5 minutes? No, how about 2 hours? Remind me later. I don't even know what that is. dx. Now let me explain how I envision this. Between any 2 points on a function, there's an infinite amount of points. So from 2 to 6, there's definitely an infinite amount of y values. Well, that's like, this is adding them all up. This is like dividing by how many there are, kind of, because we're dealing with infinity and that's impossible. But it's very similar to that. So let's do the math on it. 1 over 4 times the integral of 2x is x squared. Isn't that what you take the derivative of to get 2x? And then plus x, the derivative of x is 1. And we're integrating from 2 to 6. So 1/4 times 36 plus 6 is 42. We always subtract. Plug in 2. 4 plus 2 is 6. 1/4 times 36, I knew it had to be 9. Had to be. There's no other way it couldn't. It had to be 9. And I was actually right. I thought of this morning. So I thought, all right, well, let's not deal with lines. And what I really did is just, it's kind of symmetry. There should be the same up above as the amount below. Had to be. So I thought, could I find some symmetry in something other than a line, approximate the average value, and get close to that? So I made up an equation. And I played around with the numbers. And I thought, well, if I could find one that went from 0 to some value up here, and it was fairly symmetric, I'll bet I could get the average value very closely to this. So I thought, well, where are the same amount of y's present above as below on this from negative 2 to, it turned out to be about 3.333, I got back to the same y value. See that? Approximately. Back to the same y value. And I knew that both of these were going to be at 0. So I thought, well, if I just cut this in half, somewhere right here, I would have about the same amount above as below. So I decided, well, the estimate could be about 9.481. That's the top y value from 0 to there. If I just divided that by 2, 9.481 divided by 2, I thought the average value of all of these y's, because of some symmetry here, would be about 4.7405. Boy, was I right. Wait till you see the answer. Use our calculator to find the average value. So it's 1 over b minus a. 3.333 minus negative 2 is 5.333. Times the integral from negative 2 to 3.333 of, here's the function right here, we'll just call it y dx. By the way, that's perfectly legal on the AP test. If in the problem it says y equals this stuff, you don't have to write this stuff. You can just replace it with y and they will accept that. That's fine, as long as they're equivalent. All right, so here we go. 1 divided by 5.333 times math number 9 from 2, or is it negative 2? Negative 2 to 3.333 roughly. Well, actually, we're doing exact now. And I want this function, x to the third minus 2x squared minus 4x plus 8. And watch, I ended up being 1/10,000th off from the exact answer. Just by looking and investigating a little bit of symmetry and where I thought the average value would be. So it turns out to be 4.7404. So we're off by 1/10,000th. Now that does not mean that you just get to divide stuff by 2. You can't do that. You have to do the calculus part. Because now, if we had a function like this, from here to here, cutting this, taking this value and cutting it in half, do you see that you have a lot less up here than you do down here? So if I'm going to predict the average value, and we don't actually do this, should I move that line up to make it more even or down to make it more even? Down. Probably down to make it more even. And we probably have to adjust something because of the negative, so this is probably a bad example. But hopefully you have an idea of what is this average value thing? Well, if we add up all the y's and divide by infinity, that's our average value. The real life example that I always think of is if you want to know what the average temperature for the day is. You could probably have some computer that starts taking temperatures at 7 a.m. and takes all the temperatures for 1 second intervals till 7 at night. Add up all of those, divide by how many there are, and you get the average temperature of the day. You could, and taking the temperature at 1 second intervals would probably be a pretty accurate average temperature, wouldn't you think? Taking the average temperature every hour probably wouldn't be that great. But the point is, if you go from 40 degrees to 50 degrees, you hit every temperature for at least a brief moment in time. At least a very brief moment in time, it was 42 degrees. So in theory, or to maybe even be a better accurate average value, you could come up with a function to represent the temperature that day and use calculus to get the average value. Because how do you add up an infinite amount of values? You can approximate it. You can take the temperatures every second or every half second or every 1/4 second and get a really good answer. But if you want the exact, you have to do this process. You have to somehow add up an infinite amount of values. And that's what this is doing right there. And kind of dividing by how many there are. All right, anyway. That's a very long-winded explanation of what average value is. What are you going to do on your homework? Here we go. Find the average value of the function of the interval using antiderivatives to compute the interval. So we're going to go 1 over pi minus 0 times the integral from 0 to pi of sine of x dx. What do we take the derivative of to get sine? Be careful. Negative cosine. Negative cosine of x times 1 over pi. From 0 to pi, 1 over pi times negative cosine of pi minus a negative, so plus cosine of 0. Did I actually subtract here or not? Yes, right? I actually subtract. Someone goes, why are you adding there? I subtracted, minus a negative. That was last period. Someone asked me that. Cosine of pi is negative 1 times negative 1 is 1. Cosine of 0 is 1. So the answer, the average value, is 2 over pi. And I'm sure there's some decimal value for that. That's how you're going to do your homework. You're not going to graph it and cut stuff in half and do all that. I just wanted to hopefully show you what is average value. It's adding up all the y's and divided by how many there are. So on this one, we're going to go 1 over 2 minus negative 1, integral from negative 1 to 2 of 3x squared plus 2x. On the free response part of the test, just writing that down might be worth a point. So try not to do a whole lot of stuff in your head. You guys are losing points because of that. So 1/3, negative 1. Oh, no, I can do the integral also. I don't have to write this. So 1/3 times x to the third plus x squared from negative 1 to 2. Plug in the top value. 8 plus 4 is 12. Plug in the bottom value. Negative 1 plus 1 is 0. So the answer should be 4. The average value is 4. But isn't this 1 over b minus a times the area under the curve, right? You might want to know that for the quiz. That's really what we found. Here, I'll even help you out more with that. Maybe we can even go back to this. No, no, never mind. Let's use, I think I used 2x plus 1. Let's go from 1 to 3. 1 to 3. And, yeah, that's good. So the area under the curve would be 1/2 times, the height would be 2. This base right here would be, let's see, 2 plus 1 is 3. 3 plus, this base right here would be 7. So 20, see 10 times 2 is 20 divided by 2 is 10, right? So the area is 10. The area under the curve is 10. So what is the average value? Thank you. Yep. No. 5. How did we get 5? Yeah, 1 over 3 minus 1. So you take this area, that's the integral part, multiplied by 1 over 3 minus 1. So 1/2 times 10, the average value is 5. So the integral, or the area under the curve, is 10. The average value of the y's is 5. Because integral is area under the curve. Oh, Sarab, you won a cake raffle. Congratulations. I'm just kidding. It's a note to the counseling center. But a cake raffle would have been totally cool. Find the slope of the tangent line to the graph of that. So some review. So we go back. We have to do antiderivative in this section. Antiderivative, same as area under the curve. There's just some more antiderivative and how you work it out. You got to think, what do you take the derivative of to get this? What do you take the derivative of to get this? Antiderivative. Long-winded explanation of average value, but it's 1 over b minus a times the integral from a to b. That's just the math, the pure math of it, the mechanics of it. All right, so a little bit of review. Go away. There we go. Find the slope of the tangent line to the graph. So y prime is equal to negative cosecant squared of 3x times 3. I have not looked at the test yet, but these are usually test questions when I review. I review test questions. I don't actually know that for this one. And then we're going to evaluate at x equals pi over 12. So 3 times pi over 12 is pi over 4. So pi over 4. Cosecant of pi over 4, there's square root of 2 over 2's at pi over 4. Cosecant's the reciprocal of sine, which doesn't matter, but it's 2 over square root of 2 squared. Negative 3 times 4 over 2, that's 2. Looks like negative 6 is the slope. Find the derivative. So y prime is equal to the derivative of e to the 3x squared is e to the 3x squared times 6x. So there's the chain rule times the derivative of the inside. Your turn. Give that one a try. I gave you the answer is 1/10. And you'll have to use the fact, or use the little hint I gave you back here, this right here. These two are the same thing. Give it a try. Try to get 1/10.